My name is Charity Miner. I have served as the Classical Conversations of South Durham Challenge 4 Director for this past year and for these fine young individuals. The Greek word thesis means something put forth. The Classical Conversations Senior Thesis is an opportunity for Challenge 4 students to put forth an important, original idea using all the understanding and skills of their entire education. This is their final project in their home education. They have been trained to examine the evidence, to consider carefully the ethical implications of their arguments, and to winsomely defend a position in a setting that extends beyond the classroom. These are the goals of a rhetoric program. Teaching the art of persuasion is, as the Greeks and Romans knew, more than just a good idea. It's a way of transforming language users into up-and-coming rhetoricians, leaders ready to discern and to take a stand on what's important. Our goal is to honor the hard work of these students by providing a professional atmosphere. Please keep noise and distractions to a minimum, silence your phones, and remain seated until our breaks. Thank you so much. Without further ado, Joshua.
Quickly offer special thanks to my judges, Kristen Rudge, Brea Lowry, and Dr. Diane Martin. Thank you so much for being here. To my mentor, Kristen Rudd, hopefully she will arrive soon, and to Dr. Van Brun, whose interview offered me many insights which helped me define my thesis. Saxon Algebra 8.7, a widely adopted homeschool math text, introduces its 8th grade curriculum as follows. Quote, "We study mathematics because of its importance to our lives. As you grow into adulthood, mathematics will become even more important. In fact, your future in the adult world may depend upon the mathematics you have learned." End quote. Most math curricula assume that math's only benefit to its students is its direct utility to the real world. However, the pursuit of mathematical knowledge must be founded upon something greater than basic utility. Mathematics should be studied primarily for its transcendent ends. It should be studied because it closely corresponds to the 3 transcendentals: truth, goodness, and beauty. Mathematical truth is so unshakable that it is the most true and certain knowledge humans can possess. The Pythagorean theorem from way back in 8th grade is one of the most well-evidenced ideas in existence. Every single one of the thousands of proofs discovered since the time of Pythagoras conclusively prove that a squared plus b squared must equal z squared. The golden ratio, or phi, is the epitome of mathematical universality. From pentagrams to pineapples to snoozing pug dogs, the golden ratio seamlessly bridges the gap between mathematics and matter anywhere proportions are concerned, and reflects the fundamental alignment between mathematics, creation, and truth. But even if numbers and patterns are essentially true, would that not reinforce their status as wholly distinct from such polarizing notions as good and evil? Nothing could be further from the truth. God is a God of order, and math is a prime example of that order. It is true regardless of circumstance. It is logical, and it is comprehensible, yet wondrous, playful, and helpful. Nothing is neutral. Math is a prime example of the fact that God called all creation good. Mathematics, a set of ideas so deeply rooted in truth, cannot but reflect God's goodness as a clearer mirror than most. Mathematics is food for the soul, and God's artistic flair in the workings of his creation. It should therefore be studied according to the beauty of its nature. The most beautiful things are those which are in themselves beautiful, but whose beauty is greatly enriched when their learners understand the underlying mathematics. Consider music, the medium of every human emotion since the dawn of humanity. It is so reliant on mathematics for structure and pattern that it may be called math in motion. Stargazers behold infinite, sublime beauty in stars and worlds and galaxies, rendered far more wondrous when by clever trigonometry they understand the breathtaking scale of the night sky dance. There are many beautiful things in the world, but they are all governed by God's rules for creation, exemplified in mathematics. Though often isolated from other studies that highlight the Transcendentals represent the highest reward for studying mathematics. But mathematics may not seem like an appealing option to a student pursuing a classical education that builds up the whole of the learner. Contemporary math education contains no transcendental insights and seldom contains any insights into mathematics at all. A curriculum that force feeds students concept after concept without regard to curiosity or retention is not practical. Students would be far better served if mathematics in its current form were dropped from curriculum and replaced with shop class, logic, or basic finance instead. Creatively rearranging the order in which students learn concepts is like creatively rearranging the order of the deck chairs on the Titanic. Only when math's truth, goodness, and beauty are on full display, satisfying the intellectual, moral, and aesthetic ends of education, will math instruction rightly uphold the wondrous transcendental power of mathematics. Thank you.
I think this is on. Thank you. Thank you for that, Josh. So I have, of course, as a mathematician, been very intrigued by your characterization of math as beautiful, truthful, good, and I couldn't agree with you more. I would like you to perhaps comment on this. Philosophers have sometimes said that math in itself is true without dependence on the universe. What would you say about that comment?
I think that comment is absolutely true. Many of math's greatest jewels are contained entirely in abstraction, and it doesn't depend on the universe to exist. However, it absolutely is aligned with the universe, or perhaps the universe is aligned with mathematics, because I think to one degree or another, it's an outgrowth of God's divine wisdom. Furthermore, the universe can often inspire or suggest mathematics where it hasn't yet gone. And conversely, mathematics often has taught us many things about the universe we haven't yet discovered using basic science. Consider particle physics. Basically, all of it is described by mathematics. Even like the very basic stuff of stuff can only be described as a set of probabilities.
I have one more. So I quibble a little bit with your characterization of the utility of math as being sort of dusty and not important, because I do believe that the utility of math is actually, the goodness of math is actually inherent in its utility. That the fact that math is so useful and has allowed so many advancements in many fields is actually part of what makes math good. What would you say about that?
I would agree with that. It is definitely a very powerful contributor to math's goodness. And while it may seem so to some degrees in my paper, perhaps I should have elaborated on it further, I do not think mathematical utility is certainly not useless, but I don't think it's something to be discarded. I think while math should be primarily studied for its transcendental ends, its utilitarian ends are very crucial. I mean, I'm matriculating Tennessee State as an engineer this fall. Its utility has very often driven forward the theory of mathematics, and it's also given many people an introduction to instances where they can perhaps later see the beauty in it. Consider the GPS satellites. How do you think they can tell the difference? Like, let's say I hold an AirTag in this hand and I pass it to this hand. They can tell the difference between that because they're doing the math for special and general relativity at the same time to figure out where things are.
All right, so my question piggybacks on what she just asked. So you mentioned that by discovering math's broad capabilities, students may perceive wonder and beauty in mathematics. how would you encourage those who have been numbed by the utility of math, just the mundane aspects of it, to switch their mindset to one of curiosity to see truth and beauty?
I'd say two things that have been very helpful to me that might be very helpful to another curious student are books on it and puzzles. You can learn very much from books on the topic. It's honestly, most of my math curricula that I've studied in are of that dry, dusty character, which I denigrate, or at least think is not optimal in my paper. However, alongside those, I also read books like Ben Orlitz's Math with Bad Drawings, Randall Munroe's What If, Theo Gray's Atoms, Molecules, Reactions. I read books on the topic from people who truly get the beauty and power of mathematics, and that helped me understand it as well. Puzzles are also a very common and important medium. Sudoku is perhaps one of the best known and popular mathematical puzzles. There's also a whole lot of them. You can probably just Google a list. Things like, let's say you have a tin of brownies, it's not yet cut yet, it's just one big brownie. Some psycho comes along and cuts out a rectangle at a random shape and size from the middle of your brownie. Or not quite the middle, not even the middle of the brownie. How do you then divide the brownie evenly? It's a fascinating puzzle that betrays a lot about the nature of geometry.
So I have a question about more of the middle section. So you treat the element of truth very heavily, and the section of beauty is my favorite. I think my favorite paragraph in your whole thesis is your introductory paragraph to your beauty section. But I felt like you didn't have as much to say about the goodness. It's just a shorter proof. And so I'm going to just ask you a few more questions about that. If you can elaborate a little more on that one. You mentioned habits of mind and promoting freedom of thought and as a resource of intuition, but you mentioned joy. Do you see joy as an end that's related to goodness when it comes to mathematical ability and teaching?
Absolutely, but it can sometimes take a little bit of experience and understanding of the things that you've seen in mathematics to see that joy. Let's see, what a good example from my life, I was reading yet another good math book, Stephen Starbatz's The Joy of X. I read a 1.5-page paragraph which basically describes the essence of what an integral is, and I realized I don't really understand this yet. I read it again, I understood it a little better, I read it a third time, and all of a sudden I understood calculus and everything that calculus connects to. It's that sort of beautiful revelation that's always been a great source of joy to me in mathematics, and also to many other people who study it for the joy of it.
Can you talk a little bit more about that as the moral end? Because that's the section that it's in, how it's related to the goodness, how that's a moral end.
Because math doesn't just inspire it as a sort of like, as merely a source of the human thought or a place for that inspiration. If something inspires that sort of joy by its connection to the creation and how beautifully it connects with everything else around someone, all of the other concepts within mathematics and without mathematics, it's definitely something that reflects its goodness as a subject. Does that answer your question?
I think so.
All right, so you mentioned that the lack of understanding leads to boredom and frustration with math. You referenced the popular curriculum, Saxon Math, as one that focuses on utility and not beauty. So what approach would you use to inspire curiosity and wonder? I also like how you mentioned there are several different groups of students, those who are curious, the student that investigates. You called them true students of mathematics. What curriculum or what approach would you use to encourage that?
The short answer is that is a question many people have tried to answer, and it is outside the scope of my thesis. However, a few guidelines perhaps that I might suggest based on my own research would be curricula like Calculus for Everyone, which we took in Challenge 4 as part of the pilot program this year, definitely do a good job of both teaching the mathematics while simultaneously uncovering the philosophy and logic behind the people who eventually discovered and popularized those fields. I would say that something that focuses on mathematics as it is and not just as it can be used is definitely a good set of guidelines to follow. As I said before, puzzles are a great thing to include. Art of problem solving math is definitely something I should have given a better chance when I was learning algebra. I was too frustrated at that time because it was too difficult. So as you can see, it's very much a balancing act. Teaching is never easy. But following those guidelines, it may be very possible to create a good curriculum that upholds the transcendentals in mathematics.
So I would like to challenge a bit one of the statements you make in your paper. At its heart, math exists in abstraction, so that what is proven true in math will remain true for all times. But I would contend that actually at its heart, math exists in its instantiation, and you give examples in music, in art, its instantiation in the universe. It's actually in its instantiation, not in its abstraction. But I think that we humans can really understand its beauty and its truth and its power. What would you say to that?
Absolutely. My counter to that would be that there's a difference between our understanding of a thing and the very nature of that thing. Going back to my example of atoms and stuff, what was it? The ancient Greek idea was that anything that can be divided can again be divided. There is no such thing as an atomos, an indivisible particle. And from the world around us, that's certainly how we see it. You take a 16-ounce ribeye, you can always cut it into an 8-ounce ribeye, a 4-ounce ribeye, a 2-ounce ribeye, and so on. However, even though that's how we perceive it and how we understand it, that isn't how it actually is. At its heart, there are things that cannot be further divided. Atoms and subatomic particles cannot be broken up. So I would say that difference between how we perceive something and how something truly is the same in mathematics. It exists in abstraction, and there's so many things we can find out about it in pure abstraction, and yet a very good way for us to relate to it is when those abstract concepts and things such as Fourier, combinations, and how frequencies and amplitudes interact come out in real world things such as music.
So as you studied this topic, what was the most valuable thing that you took away studying this topic?
You mentioned the true students of mathematics phrasing from my thesis. I don't know if I should perhaps phrase it that way, because while some people may be more or less inclined to it, I would like to counter the very common notion that I'm just not a math person. Those people are math people. They can have fun with it, but it's not for me. I think mathematics should be for everyone. Its current teaching style has isolated its study only to the people who are, I would say, the most resistant to boredom. So if it is taught in a way that is truly open to other people, I've learned that it is in fact something that can be open to people, to everyone, to one degree or another.
So I kind of have a question. It's not necessarily based on one of your arguments, but almost a throwaway line that you had about we can use math for its utility, but we also have calculators. We can also use Excel. We can just pull up Apple Maps or whatever.
Yeah.
And I think what kind of makes me wonder about this is with the rise of AI and the ability for students to just use AI to write their papers, that they don't have to think anymore, they don't have to learn. What would you say? Would you say that there's value in perhaps not using some of those tools and perhaps doing math like that by hand for just the average person who might not be what we call a math person? Like, just what are your thoughts on the use of technology and getting at math to a more beautiful way?
We teach our students arithmetic before we teach them to use calculators. That part of contemporary math education is in fact something that I do agree with. You shouldn't be using a tool that circumvents something if you don't at least have some sense of what you're circumventing. So I do agree that we need to understand the basic concepts before we use the tools. That being said, once we understand the basic concepts, the tools can be a great boon to us. Have you ever heard of centaur chess? It's where a person or team of people constructs a chess AI like the famous Deep Blue that beat Garry Kasparov, and then the machine does the tactical movement, but they make the strategic plays, working together. A human with an AI to deal with some of the nitty-gritty details can be a very powerful combination, only because the human understands the mechanics of chess as a whole. So absolutely, calculators can be a very powerful tool in the hand of a capable mathematician, but they must understand the underlying concepts on a great level first.
I also had a question about the high tech, just to piggyback off of her. All right, so you kind of sort of answered it, but I'm going to give a little bit more. So is there a way to use high tech, modern tools and develop or maintain an investigative mindset? Do you think that one use of the other would diminish the other? Because we're living in a high tech society, so the more that we use that, do you think it would diminish the investigative mindset? Or do you think there's a way to bridge and blend and continue with our high-tech society and continue with our investigative mindset?
I think there certainly is a way to bridge it. Most of the people I've met who are mathematically inclined have found some level of balance to strike in that regard. It's not just, and it's certainly the machines that exist now. Sure, you could take a pixel grid and do pixel counting of the Brownian example from before to find out exactly what the area is and where you can divide it, but that doesn't prevent you from trying to work it out yourself with a pencil and paper. Murthermore, the machines that we use, like we shape our machines shape us. There's so many mathematical problems that have become much more prominent and much more possible to study using machines. The interesting discovery of the Borwein integral is a topic that connects very many important concepts of mathematics. Someone discovered it's like a very certain integral computed to exactly pi up to a point, and then all of a sudden it computed to pi minus 100 billionth of a percentage point. And discovering why that happened connects so many different concepts. So there's certainly, we shouldn't let the machines do all the work and do all the thinking for us. But once we have some understanding of the underlying structure of everything, they can be a great boon to our understanding as well as our utility.
Okay, I think it's very easy when I look at your arguments to see that math is beautiful, especially with the Fibonacci, how that shows up in nature and things like that. I think it's a very easy way to say yes, math is beautiful, and your proof about math being true is also very convincing. But what would you say to someone who said, but math isn't good, it's neutral, it's just a tool, it doesn't have anything to tell us about morality? How would you refute that?
I mean, as I mentioned in my paper, the arguments from it can help pursue freedom or it can bolster humanity could be good places to start. To someone, if I'm speaking to someone, however, who's thinking about this from perhaps an agnostic perspective, then I would just say there's hardly any beauty without anything higher to give it beauty. And my central argument, the one for goodness that I brought up primarily in my abstract presentation, is that it is God and His dominion over it that gives it beauty. So, talking to a Christian, I would highlight exactly that. It may be an outgrowth of divine wisdom, it may be part of creation, perhaps both at the same time. And of course, it interacts, the way that it supports creation, something that God called good, and we can see, broken or not, it is very good. The fact that mathematics enables everything that happens to happen certainly makes it very good from a biblical perspective.
I was also going to ask something about the neutrality, because I had underlined that. Nothing is neutral. That's often said about technology too, that technology is neutral and that good people use it or bad people, but I don't agree with that. However, I think there's another way we might think about the non-neutrality and the goodness of math in terms of orderliness. If we think of creation coming out of chaos, God created orderliness out of chaos. We can see that math is the ultimate instantiation of God's orderliness, and maybe that might be a way for your argument to further bolster goodness, God's goodness and truth. Would you want to comment on that?
As in, to note that not only is math orderly, not only does it reflect God's order, but that it is the ultimate example of his orderliness in creation. I think I have to agree. There's a cartoon that I once saw, which is like ranking fields by purity. Sociology is just applied psychology. Psychology is just applied biology, and so on all the way down to chemistry is just applied physics. It's nice to be on top. Way over on the left, mathematics. Oh, sorry, I didn't see you guys over there. Because mathematics is such a pure field, and the superlative or the extreme in so many different ways. The fact that it's something that can and does exist entirely in abstraction, and its order entirely separate from anything that has to happen in the real world, I would say that yes, it is a superlative example of God's order in his creation.
Last question.
This quote keeps staring at me, so I have to ask about it. You said, play is human and math encourages play. How would you like to expound on that a little bit, please?
Great question. Anytime you're approaching a problem that isn't just a drill and kill, 3x plus 17 equals -9, find x, there's always a lot of different ways that you can look at it, and you can literally play around with the idea. It's like going back to the brownies from before. If you think about it, it's like, what if I made 10 cuts straight down and 10 cuts straight across? Most of the brownies would be exactly the same, but the ones left over, what would they look like? Can I shuffle them around or rearrange them? Or perhaps, what if the center of the brownie, I can imagine spinning a line around the center of the brownie cut in my head, and also the center of the brownie tin. What if those centers align? And then you discover, if those center lines align, then you'll actually have found the perfect way to cut the brownie in half. You cut through the center of the brownie tin and the center of the brownie cut, and the areas will be exactly the same. So play is definitely a very human aspect. From babies to toddlers to adults. To any men here who haven't been skeet shooting at Drake Landing, absolutely recommend it. It's golf with shotguns. We just love to play. And mathematics is a very pure and accessible way to do that for people of all ages and understandings of mathematics.
Thank you, Josh. We will adjourn for a short 5 minutes and swap out judges and prepare for our next 2 defenses. Thank you so much.